Hello everyone to this tutorial about the logistic regression. So what is a logistic regression and what is the difference between the logistic regression and the simple and multiple linear regressions? In the simple and multiple linear regressions, we are trying to predict a continuous value, like a price or a cost. So the continuous value can go up and down. But in logistic regression, we need to predict an event. And an event could be either 0 or 1. So it is a categorical. In this case, when it's 0 or 1, that means it is binary. But for example, we can also try to predict an event of somebody to be like tall, medium, or short, or for something to be good, fair, or bad. So the type of the value here is categorical. This data set is about observations from one of the companies about its customers. And in the first column, the age of the customers. The second column is the number of years they are customers with the company. The third column is the gender, and the last column, if that customer bought or didn't buy a product. So for example, the first customer, the age of the first customer is 36, and that customer is buying from the company for 4 years, and the gender of that customer is male, and that customer didn't buy the product. While the third customer here, the age of that customer was 26, and that customer, he's a customer of the company for 5 years, and the gender is male, and that customer bought the product, and so on. So here the event either 0 or 1. So the logistic regression model is built to predict either 0, do not buy the product, or 1, buy the product. In the linear regression, we can represent the model as a straight line that pass through the values, but in logistic regression, we cannot use a straight line. Because we say in logistic regression, we use a binary system, which means that 1 when the event happened and 0 when it didn't happen, as we mentioned before. And we have something between 0 and 1, which is 50%. So what is the threshold of the 50%? When the predicted value in logistic regression is equal or greater than 50%, that means the event is more likely to occur. And when the predicted value in logistic regression is less than 50%, that means that event will most unlikely to occur. In logistic regression, we cannot use a straight line to represent the slope line because we have only 0 or 1. And the straight line go above 1 and below 0. And as you know, in the probability, we don't have something less than 0 because 0 means that event 100% will not occur. And when the value is 1, that means that event 100% will occur. So 1 is 100%, 0 is 0%, and the value in between is 50%. So the slope line in the simple linear regression is going below 0, and it's going above 1. So how we are going to fix this problem? This problem can be fixed with a sigmoid function formula. Sigmoid function formula equal 1 divided by 1 plus e to the power of minus x, which equal to the e to the power of x divided by e power of x plus 1. So with using this formula, we can solve the problem of the slope line. In this case, the sigmoid function formula will make the line start bending gradually when starting approaching the 1 value until reach 1, and after that it will go on a horizontal line on 1. And the same thing, when the lines start going to 0, it start bending gradually, making a curve. And so that's how the sigmoid function fix the problem of the slope line. How does logistic regression work? Let's have a look at this example to understand how the logistic regression work. Let's take the previous example that we talked about, observations about the customers of one of the companies that have the age, number of years customers with the company, the gender, and if that customer buy or didn't buy the product. And let's try to take some of these value and fit these values on the line here and see how the logistic regression will predict if that customer will buy or not buy. Let's take age as an example here, because we cannot use more than an input or more than an independent variable here on this graph, the y and x axis graph. We can only show one variable here, or one independent variable, or one input, and I will choose age, and I will put age here, and I will start with 5 years, 10 years, 15, 20, 25, 30, 35, 40, 45, and so on. So we have the ages on the x-axis, and the probability on the y-axis started with 0, 50%, and 1. And let's take some values and examine these values. I took the example when an age of a customer is 20. So if we draw a vertical line from 20, that means the point will be here. So after we draw a horizontal line, we see that the horizontal line meets the y-axis on 10%. And 10% is much lower than 50%, which means that this customer will not buy the product. In the past, this customer didn't buy the product, but using the model, we will use the model to predict in the future that a 20 years old customer will not buy a product. And by the way, here I'm just showing one input or one independent variable. In logistic regression, we are going to fit all the inputs, and the prediction power will be based on all the inputs, not only one input. So, as I said, that this customer will not buy, so that means that customer will be on 0. So this customer will be on 0, that means that customer will not buy. Let's take a customer with 40 years old, and if we draw a line, vertical line, to the regression model here, we'll find that this point will fit on this location. And if we draw a horizontal line to the y-axis, the horizontal line will meet the y-axis in a point. This point is 70%, and 70% is higher than 50%, which means that this customer bought the product.